Hi there, this is Rahul Inchal, and today we are going to learn, or rather, not learn, we are going to analyze ABC call volume trends analysis. Fine, so this is the project which I have got, and I'm supposed to follow it. And let's see what is the Excel file looks like. So first column which we have is the agent name, which is like again not very beneficial, or not we are not required for that anything. We don't require this. Agent ID is also unique, so we don't require it. Customer's phone number, of course, again this is not required, because this is like the phone numbers can't be displayed, and this does not give us any insights. And also the phone number has not been provided because of the confidentiality purpose. Queue time in seconds is given, like how much time it has taken for the customer to answer the call. And this is the date, of course date I don't have to explain. And this is the shift timing. Say for example, what do you mean by shift timing is when the shift has started. So normally the IT sector, the shift time starts from the morning shift starts from 9 a.m. Okay, and the night shift say may differ. Okay, all right. So yeah, and then time bucket. Now time bucket is all those employees who come who are supposed to work in this time bucket. So for example, or it is trying to so 9 to 10 is a 9 a.m. to 10 p.m. 9 a.m. to 10 a.m. time slot, in which how many calls were there, how many call seconds. So these all are the things. So for example, see, executive 42 or agent ID, this guy in this bracket 9 to 10 a.m. had a call of 96 seconds, and this is like hours, a minute and seconds. This is the conversion of it, and this is like different. So again, like 9 10 9 10 9 10, there are lots of people who are in the bracket of 9 to 10, and then 10 to 11, 12 to 1, and 1 to 2, and further so on. Then now this is time bucket, which is very crucial. We are going to analyze a lot of things onto this as well. Duration, self-explanatory. Seconds is again self-explanatory. Call status, there are only three call status, that is answered, abandoned, and transferred. Again, like answered is a person, like the customers have picked up the call, and the call had like the duration happened of that call was 96 seconds. And then abandoned was like they cancelled the call, and transferred is the transferred the call. Wrapped is there, ringing is there, and IVR duration. IVR is a so IVR, let's know much about it. So IVR, IVR so IVR is interactive voice response, is an automated telephone system, that is like AI generated telephone system, that combines pre-recorded message or text to speech technology with a dual tone multi-frequency. Now these are like very too much of details to come to. Now IVR, so suppose whenever we call customer care, right? Whenever we call customer care or any other whenever we have ordered something or so there is one tone which comes, a lady or a guy is talking about something, right? So that is a IVR call. All right, so this is a short introduction about our data set which we have got. And also I would urge everyone to study about your data set thoroughly, because that is how you are going to analyze this analyze and you will get to know what am I supposed to analyze and what am I analyzing. All right, so let's see. And we have got some set of questions. Now this is the report which I have made. Now we have got some set of questions that calculate the average, and this that, and a lot of questions. So we are mainly going to focus on 4 questions, and based on those 4 questions I have I'll just transfer myself here. I have like derived different tables onto it, pivot tables onto it, and we will be dealing with each and everything in a bit. Okay, let's see what my, now this is the report, and this is the project description, guys. I would urge you, I would request you to read the project description thoroughly, because I don't want to, like, I have already read this, so I don't want to like waste much of a time in recording this video. Yeah, so now tech stack used is Microsoft Excel, of course. In that I'm visualizing, and Microsoft Word or PowerPoint. So I have tried to prepare this in Word. So yeah, yeah, now the first question, what is it asking is calculate the average call duration for all incoming calls received by an agent. Okay, in each time bucket. See, I was telling you about 9 to 10 a.m., 10 to 11, 11 to 12, 12 to 13, 13 to 14, and this is in 24 hours of format, guys. 9 to 9 p.m, 9 a.m to 9 p.m. Okay, so now this is the average. So let's see in the Excel sheet itself. So it is like that, it is like that. See, now these are my pivot tables, pivot table this is my pivot table settings. All right, so in which I've given like access, I've taken time buckets. All right, so this is messed up, you can see it in here, time bucket, and in this I have taken average of call seconds. So you just have, you don't have to do anything. You can like call status, no, call seconds, right? Call seconds, fine. Call seconds you can drag over here, and then if I wanted the average, so I've taken the average, fine. And if you want to show it as a percentage value, percentage of the column total can also be taken, but I don't want that, so I will just redo it, fine. So this is my first graph, which says what am I trying to, what am I what am I seeing in here is traffic is too less, way too less in the time frame of 12 to 1 p.m. all right, and comparatively it is very much or comparatively similar in 10 to 11 and say what, yeah, 90 to 20, right? So 7 to 8 p.m. So this is the time where agents have connected to a lot of calls maybe, and they have talked to the customers too much in these things. So what insight I can draw out from in here is we can focus more on these areas, or we can dedicate more number of agents onto these time slots, because a lot of calls are getting connected and a lot of average is there in for this call seconds. Now this gives me the first answer, fine. So now what insight we can take here is time bucket is measured in row, and okay, now this is taken. The total average call duration were answered by the agents is 198.6 seconds. Total average in a day was 198.6 seconds. The average call time duration for all incoming calls received by agents is the highest in 10 to 1 and 7 to 8 p.m., which is what we have seen by the graph. The average call duration for incoming calls agent least in between 12 to 1 noon, fine. So this is one insight which we have taken. Now second question, what it says is show the total volume by total number of calls coming in via chart, like graph, which they have tried to see calls versus time. You can select the bucket list. Okay, now see what I have tried to do in here is, so let's open the Excel. Guys, the Excel will respond very lately, or like it will take some time, because it is a high volume Excel file, because the data is too huge, and also we have tried to visualize a lot of things as well. Again, in the first row table we have taken time buckets, and second column is given by the count of customer phone numbers. So how many calls have been connected, okay, and how much in the percentage, how much calls have been connected in the percentage. So these both are the same values, okay. It's just that this is in the count format and this is in the seconds format. So the graph you can visualize it from here itself. So see, it has same values. So if you see, it has same values. So 9588 is the count of the call values, okay. Now this is the orange one. You can't see the orange one because so orange one is like comparatively way below. So if you can see these values, so this is the values of count of call seconds, okay. Now this is count of phone numbers. So phone number is too much, so it is, the graph has gone way too much. So again, what insights, what can we draw in here is, from here we plotted time bucket, okay. We measured count of time as a percentage column total. The customer call the most between 11 to 12 noon. The customer call the least between 8 to 9 p.m. all right. So again guys, it goes vice versa. So for example, in say if someone wants to sell something, the agent will call, and if someone is responsible for the quality assurance or the customer agencies, then at that time the customer will be called, customer is going to call the agents, fine. So this is one thing, fine. Now next question is very breakthrough question, very important questions. In this we have assumed a lot of things, so let's see what it is asking for us to do. As we can see, current abandon rate is approximately 30%. Okay, propose a manpower plan required during each time bucket between 9 a.m. to 9 p.m. that is morning shift. And guys, from now onwards, for 9 a.m. to 9 p.m. I'm going to say morning shift, so that can be self-explanatory. If I'm mentioning morning shift, that means the 9 a.m. to 9 p.m. To reduce the abandon rate to 10%. Previously it was 30% and now it is 10%. That is, must calculate minimum number of agents required in each time bucket, so that at least 90 calls should be answered out of 100. Now that is 90%, fine. So now for that we have taken some normal example from IT standard point of view. So total working hours by any company is again 9 hours, which is like compliant by the government of India, the IT labor law. 9 hours he or she are supposed to work. And break, say for example in my ex company, the break was supposed to be 1.5 hours, that is 1.5 hours. 1 hour long break and half hour is the short break. That is like an employees or agents divide it into breakfast and the lunch time. So 1 hour for the lunch time and the half an hour for the breakfast time. Now IT downtime, say for example if they are working in a say, now this is average I'm taking, guys, okay. In a single day, 9 hours is the total shift hours, 1.5 hours is the break hours, and IT downtime, say suppose there is an issue with the internet or the computer may lag, so that is IT lag time, this is 0.5 hours, so 30 hours of that. And every day there is some sort of meeting, right? So what is the agenda for the today, and what is the what are we supposed to do today? So your senior or manager is going to tell you. So that is, say, meeting, we conclude it for 1 hour. So the actual working hour by the agent is 5 hours. You subtract everything by this. So 9 minus 1.5 is, say, what, 7.5, 7.57, 7, okay, what's wrong, 9, 8. Okay, so you can consider these things, okay guys. Average you can consider by 5 hours, fine. I have taken 5 hours. There must be some more things which can cause in between, and the total average working hour for a guy would be 5 hours, okay. I have taken that, okay. And you can for the sake of calculation, you can take 6 hours as well, 4 hours as well, fine. It's up to you. Now that I have taken it, fine, so let's go on to this. We will calculate, yeah. now this now we have tried to plot a graph, that is count percentage, fine. So of what? Count percentage and average of call status. So I will mention it, and average of call status, right? And because and average, okay, average, because this is the count. Now abandon, let's see what is abandon and what is, so abandon, hold on just a second. I'll just try to paste it. Yeah, so see, abandon, how many calls were abandoned is 34,403, fine. And what is the phone number, count of the phone number which was connected? Count of the phone number which was connected is 29,016, or rather 29.16%. And of course there will be no average call seconds, right? Because that the call was abandoned, fine. Now how much was the answered is 82,452 customers have answered. And now this is all for a day, guys, okay. 69.88 percentage, and average was 198.62, which we have seen in the previous questions as well. Transfer is like very less, 0.96, almost 1%, fine. Now this is 34,000 and 29.16% and 0 second, yeah. Answered this and this, the graph states everything. Now next question or next part of it. So now what we are supposed to say, what we are supposed to do, our question was asking us to find out from 60% to 90%, right? For every 100 call, 90 calls should be answered, which means 90%, right? So first the productivity was 60%, now the productivity is supposed to be 90%. For that, how much more men or agent are we supposed to hire? For that calculation we are dedicated for that. All right, so for that I have taken first day, okay. Now first day, how many hours has been worked by the people or by the agents? So 1st January I have taken 67,664 seconds of worth of time is been spent by the agents. All right, so that is equals to 187.96 percentage of or rather sum of hours. So 187.96 hours of callings or answered have been happened. Total agents working can be calculated. Now guys, how can we calculate now? So in the previous slides I have explained you, one agent works for 5 hours, okay. So total agents working can be calculated by the average calls on a single day divided by the total time spent by one man in a single day, right? So 187 187.96 divided by 5 is 37.59. Okay guys, 37.59. Again guys, we cannot take total agents as 37.59 because it's an agent, right? Like it's a whole volume, like it's a whole number. It can't be in points because you can't dedicate one and a half of the person to a certain task. So but yet I've taken this into consideration, point 0.9 also into consideration, because what we want is the total final value as the whole number, not the previous calculation, even though that is the man. Fine. So if agents are working for 5 hours a day and 60% calls are getting answered, okay, which means, like, I'll repeat it again, if agents are working 5 hours a day and 60% calls are getting answered, which means, like, that is the previous thing what was happening, and if we want 90% of the calls to get connected, we apply unitary method, like in the 7th or 8th, in the 9th class we have studied, right? So unitary method. So if 60% is 5 hours, or rather 60% is 37.59 people, so 60% work for 60% is the call which is getting answered, and that is equal to the total number of agent, that is 37.59. Then how much agents would be required for me to convert that 60% to 90%? That is 90 into 37.59, 37.59 divided by 60. All right, so that comes out to be 56.3, and I have rounded it off to 56 agents. Fine, 56 agents. Now this is the table, guys. Okay, now this is time bucket, this is call of count second, or count of call seconds. Now this is in percentage, I have taken it into the point value. Now the man required for 9 to 10 a.m. slot, I required 5 more men for that 60% to convert to 90%. And similarly in the 10 to 11 column and 10 to 11 time bucket, I need 6 more people, because and 11 to 12 I need 7 more people, and similarly goes on to still, like, by this. Fine, I hope you guys have understood this calculation, guys. This is a simple calculation which you can consider. Fine. So what we have seen from this chart is, or from this analysis is, first we decided to draw a pivot table. Now I did tell you how to make that. Then we calculate the average of abandon, and this. Fine, 29% of the calls are abandoned, 1% is transferred, while 70% of the calls has been answered in the daytime. Total agent are required to answer 90% of the call per day is 57. Fine. The minimum number of agent required for the each time bucket is calculated by 57 into count. Fine, that is calculated in the previous column. Now guys, I have taken, like I did mention this, like I did make some mistake. Now I have taken 57 here. It was previously has to be 56, that I calculated, and by mistake I have taken that in writing. I beg your pardon for that. Fine, so this is, I hope that you guys have understood. Fine, so 56 more people, or 56 people we need to convert that 60% to 90%. Fine, so I hope that you guys have understood. Now next question is, let's say customer also call this ABC insurance company in night, but didn't get answer, as there are no agents to answer. This creates a bad customer experience in the insurance company. Suppose every 100 calls that customer made during 9 a.m. to 9 p.m, customer also made 30 calls in night between the interval of 9 p.m. to 9 a.m, and distribution of those 30 calls are as follows. Okay, now guys, this is the distribution which we have got. Fine, now this is very important. You have to see distribution of 30 calls coming in night for every 100 calls coming in between. Fine, so this is what it is. Okay, now total number of agents required is calculated by, let's see, average calls daily is 9 a.m. to 9 p.m. Okay, now this I will show it in 4a or 4b. Yeah, 4b rather, hold on. No, yeah, 5. See now. See, now this is the graph, guys. This is the table. Fine, so this is the total of this is 5130. 5130 is the average call. Now this is the average, right? So average call daily from 9 a.m. to 9 p.m. So for night, what am I supposed to do? What I did is, now 30%, right? So for every 100 calls, 30 calls were coming in night, right? For 30 calls, see, read this, distribution of 30 calls coming in night for every 100 calls coming between the morning shift 9 a.m. to 9 p.m. So for every 100 calls which was coming in the morning shift, 30 calls comes in the evening shift, in the night shift. So basically what it was, 30% of the morning shift in the night shift, right? Night shift, 30% of the calls which is coming. So that is why I calculated. So average call which was coming, in the morning shift, I've taken the 30% of it. So what did I do? N3, that is 5130 into 0.3, and I've rounded it off to zero decimals. So 1539. So for every night I need 1539. So for every 100 calls in the morning shift, 30 calls in the night shift, right? So 1539 seconds of 1539 average calls have to be there in the night shift. Fine. So now additional hours, how did I calculate this? Is N4, that is 1539 into 198, that is per day how much calls is getting, like how hours of the call. Fine. So I want this 9%, right? 90% of this, and divide by 3600, so as to find the total hours, right? So as to find the total hours. So 76 hours has to be needed. Now how did I take this? Is one man work for 5 hours, right? One agent work for 5 hours. So total hours is required is 76. So I have divided 76 by 5, that comes out to be 15 hours. Again guys, this is subjective, this is really subjective. People might have taken like 16 hours or 17 hours, or people might have got like agents require 16 agents, 17 agents, or maybe. Now this is all purely based on the calculation or assumption what you have taken. So the assumption which I have taken is 5 hours this guy works out. Fine. So this is the agents which we require. Fine. So now we know that 15 agents is required. Fine. So now 15 agents is required, and the call distribution we have given, like we have got like 3 calls from 9 to 10. So I've converted it into the tabular form column. Now total how many calls? 30 calls were happening. So how much is the percentage? That is 0. It is like 3 calls, right? So that is 10%. So 10% I've converted into I've converted it into decimals, so that the calculation is easy. Now this is guys, the 15 people are required, but when I calculate it, I am getting the sum as 19. I am getting the sum as 19 because if you see, I have like rounded it off to 0. So if I round it off to 2, so what I will get is, see, now I will get. But then again guys, I cannot dedicate 1.5 men, right? I cannot dedicate 1.5 men. So what we can do, so we can do it, we can dedicate 2 hours in here, and two agents in here, and 1 agent in here as well. But that will not go with the calculation, right? So this is just for a calculation. So we can like dedicate 1 more column onto it. This is purely based on the manager's decision, whatever he is going to decide. We as a data analyst is going to be mainly focused on the numerical values. The decisions is going to be taken by the higher officials or authorities, right? So my point of view is, we are going to give them numbers, and they are going to take the we are going to tell them the insights and numbers, and they are going to take the decisions, right? They are the worthy ones. So I cannot, like, manager cannot dedicate 1.5 men for the time slots, right? So that's why I've rounded it off to. You can do that. Fine. So that is also, now this is what it is required to. Fine. So I hope that you guys have understood about this. Now this is the table which we saw there, and again, like, if I have rounded it off to 0.5%, so I've rounded it off to 2 decimals, then it comes out to be 15. But now it is coming out, when I round it off, so it comes out to be 19. Fine. So I hope that you guys have understood. Let's see what is the insight which we can take. And we first calculated, again I have explained you all these things, so you guys can go ahead and check it out. The customer calls the least in the evening, again least in the evening, so the company can reduce the number of agents at the time of answering the call at that time. Now this is the insights which as a data analyst we can give. Again, the final call at the end of the day is going to be taken by the manager, or your team lead, or CEO, CMO, or whatever these guys are going to take. Fine. So yeah, the company can hire 15 customers support agents for the night shift work. The company can shift some of the day workers to the night shift. The employees who are working from 9 a.m. to, that is morning shift, the manager can change some of the worker shift from 5 a.m. to 2 p.m. as well, and some workers can also be part of 2 p.m. to 11 p.m. to get most of the calls answered. But guys, this is like, I don't think so this is most feasible, but this is of course an option, but this is not feasible as far as the employees are concerned. We have to take care of them as well. So I don't think so this can be taken consideration. But hence I mentioned the company can take the employee divided into three parts too. So the agent always are available for the 24/7. We found there, we found some, I did found some outliers there, but again, that is not of any use. So if we have taken into consideration that, or we have taken out the outliers, the answer would have been different. Fine. So this is the result, and I have learned and gained a lot of stuffs, and I hope that you guys have understood whatever I've tried to tell you. And I'm sorry if I was a bit too fast, I was in a time constraint. Fine. So you guys, like, I have uploaded these this my workings into my GitHub. You can like directly search my name and you can access that as well. Thank you so much. This is Rahul Inchal signing off. Take care.